I'm going to do examples 1 and 2 simultaneously. So we are going to round this number, 736. We're going to round it to different place values starting with the tens place. And we're going to round this using the traditional rules for rounding, but then we're also in example 2 going to use the number line to support that or show how we could also find that using the number line. So let's start with conventional rounding. So I have the number 736, and for part A, I'm going to round that to the nearest 10. So what's in the tens place? Well, right now, the 3 is what's in the tens place. So I have 700s, 3 tens, and 6 ones. So the rules that we went through for rounding say I'm going to look at the digit to the right of the one we're rounding to. So since I'm rounding to the tens place, I'm going to look in the ones place. And that's the digit I'm going to use to decide whether I round up or round down. So if that number is 5 or higher, then we're going to round up. So in this case, I am going to round up. What does it mean to round up? It means that I'm going to add 1 to this digit, to the 1 in the place value I'm rounding to, in this case, the tens place. So I'm going to still have a 7 in the hundreds place. I'm going to increase the tens place by 1, so that becomes at 4. And then everything behind the tens place becomes a 0. So when I round this to the nearest 10, I get 740. Now, how can I show that as well using a number line? So when we do this with a number line, what goes on your end ticks, okay, it's not really the end because number lines go forever in both directions, but the ticks that appear on the end of the part of the number line that you're showing, the numbers that go on your end ticks need to be different depending on what you're rounding to. In this case, I'm rounding to the nearest 10, right? So I was going to make a decision. There was a 3 in that tens place. I was either going to leave it the same if I rounded down. I was going to leave it the same, meaning it would have been a 3 in the tens place, and then zeros behind it would make that 730. Or I was going to round up, which means I would increase that by 1, and everything behind it becomes 0, so 740. Or in other words, the 2 tens, that 736 is in between. It's in between 730 and 740. Those are the multiples of 10 that it's in between. So those are the numbers that would go on the end tick. That's going to be different for parts B, C, and D because the end ticks will be different depending on what I round to. Since I'm rounding to the nearest 10, it's 730, 740. I'm going to go ahead and put the labels on the other tick marks here. So if this is going from 730 to 740, then this would be 731, 732, and so on. So I'm going to go ahead and label those. And then we want to plot the actual number, 736. Sometimes it'll be on a tick mark, sometimes it won't. In this case, it is on a tick mark. If it's not on a tick mark, you also want to label that number exactly. But in this case, it's already labeled 736. So then how can you figure out, just using the number line, not using the standard rules for rounding, how can you figure out what you want to round this to? You just look and see which of these end ticks or which of these tens is it closer to. So is 736 closer on the number line to 730, or is it closer to 740? And we can see it's definitely closer to the right end of this number line. So we can say 736 is closer to 740 on the number line than it is to 730. And so that's why this ended up getting rounded to 740 because it's closer to that one. And that's all we're really doing when we round is we're just seeing which 10 or which 100 or which 1,000 or whatever we're rounding to, which one is it closest to. So then let's do this again for part B. So we have the same number. We're going to get totally different answers and totally different number lines depending on what we round to. This time in part B, we're going to round to the nearest 100. So what's in the hundreds place? Right now there's a 7 in the hundreds place. So if I use conventional rounding, that tells me I'm going to look at the digit to the right, which is the tens place, and use that to decide whether I round up or down. Since that is a 4 or lower, right? 3 is 4 or smaller. That means I'm going to round down. What does it mean to round down? It means I'm going to keep that digit the same. So this is going to stay a 7 and the 3 is going to stay a 3. But then anything behind the one I'm rounding to, right? So, sorry, I said that wrong. So since we're looking at that to decide what we're going to round to, we're going to round down. That means that the 7 is going to stay a 7, right? And then anything behind the digit we're rounding to, behind the hundreds place in this case, becomes a 0. So this ends up rounding to 700. And then let's do that using the number line. So which two hundreds is 736 in between? Well, it's in between 700 and 800. And again, that's all we were really deciding, right? If we have the number 736 and there's a 7 in the hundreds place, we were either going to round down, meaning that that 7 would have stayed a 7, or we were going to round up, meaning we would have increased that by 1. And either way, the rest becomes 0. So we're deciding whether to round down to 700 or round up to 800. So those are the end ticks this time, right? The end ticks are totally different depending on what you're rounding to. All right, so if this is between 700 and 800, halfway between is going to be 750, which means I'm counting by tens here. So 710, 720, and so on. And then we need to actually plot our numbers. So 736 is in between 730 and 740. So I'm going to use my filled in circle, and you do need to label that as well. 736. And then I could decide what to round to. So if I pretend that I don't already know this rounds to 700, I would look and say, is it closer to 700 or is it closer to 800? And in this case, 736 is closer to 700 on the number line than it is to 800. So that verifies the rounding to 700. All right, let's do this again for part C. So 736, we are rounding that to the nearest 1. And a lot of times they won't say it that way. They'll say round to the nearest whole number. If they say round to the nearest whole number, they mean round to the ones place. So I'm trying to decide, am I going to leave that as a 6, meaning round down, or am I going to round up, meaning that would bump up to a 7? So like when I do this with my number line, this is going to be deciding between it being 736 or 737. So this is getting a little ahead because we haven't done decimals yet, but technically 736 is the same thing as 736.0. So it's implied that there are zeros behind the decimal. So if we're rounding to the ones place using the standard rounding rules, then we would actually look at the digit behind that. In this case, that's a 0. And so if that digit is 5 or higher, we round up. If the digit is 4 or lower, we round down. 0 is definitely 4 or lower, so we would round down, meaning that the 6 stays a 6. And then everything behind that becomes a 0, because everything behind that is already a 0. It's already implied that there's a decimal point and zeros behind that decimal point. So this just stays at 736. So that's using the conventional rounding rules. And then in terms of how do I do this with the number line? So what are the two ones that we were deciding between? We were either going to round down to 736 or round up to 737. I'm not going to worry about this. I'm not expecting you guys to label these because we're not doing decimals in MAE 201. So when you get to 202, that'll be different. But so don't worry about filling in everything on this particular number line. But we will plot our point. So our point was 736, which is right here. So 736, is it closer to 736 or to 737? Well, it is 736, right? So it's definitely closer to itself than it is to 737. So that verifies we round this to 736. All right, and then let's do one more. So again, the same number, 736, but we're going to round it to the nearest 1,000. Now, right now, there's not any digits in the thousands place. I've got 6 ones, 3 tens, and 7 hundreds. Technically, and if you want, you could write it, technically there's a 0 in the thousands place. Since there's nothing there, we would say there's no thousands or 0 thousands. So when we use the conventional rounding rules, this is the place value we're rounding to, so I look at the digit behind it. And if that digit is 5 or more, I round up, and in this case, 7 is definitely 5 or more. So that means I'm going to round this up, which means the digit I'm rounding to, the thousands place, increases by 1. So that increases from 0 to 1, and everything behind the place value I'm rounding to becomes a 0. So to the nearest 1,000, this becomes 1,000. So that's rounding 736 to the nearest 1,000 using the conventional rounding rules. What about if I'm going to use the number line? So the whole idea here was I was going to round this to the thousands place, which means I was going to look at the digit behind it to decide what to round to. If that digit was 5 or larger, then that means I'm going to round up to 1,000. If it was 4 or lower, that means I was going to round down, which means it would have stayed 0 in the thousands place. So the two thousands that this is in between would be 1,000 and 0,000, or in other words, 0. So those are the two thousands that this is in between, 0 and 1, right? 0,000 and 1,000 is just 0,000 is just 0. So let's see, halfway between 0 and 1,000 is 500, which means I'm counting by hundreds. So I'll go ahead and label all of those. And then let's label 736. So that's going to be somewhere between 700 and 800. Put a fill in circle and label that. And so we can see if I'm trying to decide between 0 or 1,000, 736 is definitely closer to 1,000 than it is to 0. And so that's why we rounded this to 1,000.